Talk about drawing a logarithm graph. So you have to understand this form of a logarithm graph. So this is gonna be let's say this, then this is gonna be x plus p. Alright, so I gave it to you in this form for a reason, so I want you to know the parameters. So this is the vertical asymptote. So in the logarithm graph, we have a vertical asymptote, just like the hyperbola, right? In the hyperbola, we've got both the horizontal and vertical asymptote. In the logarithm graph, we've got the vertical asymptote. So for instance, if you have a graph that says f of x, or let's just say y, let's just say you've got a graph that says y is equals to log 2, okay, log 2, and we've got x, let's say plus 1. This graph, when you draw it, you already know that it has got a vertical asymptote, but it will be the opposite sign. With all functions, whenever it comes to p, it's always the opposite sign. So it means it will be at -1. So it's going to be a vertical asymptote. And then what you have to do is to find the x-intercept. So x-intercept y is equals to 0. So how are you going to solve this? So x-intercept y is equals to 0. So the first thing you must know is, first of all, how to convert exponential to logarithm graph. So for instance, if we've got maybe 16 and we've got 2 to the power of 4, when you convert it to logarithm, the exponent always becomes the subject of the formula. Then we've got log, and then the base is still the base, right? And then we put 16 here. 16 is no choice but to go there. So this is pronounced, this particular portion is pronounced as log 16 base 2. So the base is always the base. So that's how it is. So if you've got maybe 2 to the power of y is equals to 16, when you convert it to a logarithm graph, it just becomes y, the subject of the formula. So then you've got the base of 2, then you've got 16. So the exponent is the subject of the formula, the base is always the base. Then this part has no choice but to go there. So that's what you must know. You have to know that, and also backwards. So for instance, if we have got log, let's say log maybe log 2, and we've got maybe 3. Okay, this is just an example. It's not realistic. Or matter of fact, let me put a realistic example. Let's say this 8, and let's say this 3. So when you convert it back to exponential graph, we already know this is the base and this is the exponent, right? The exponent is always the subject of the formula. Then this has no choice but to come there. So that's what we have. So that's what we have. So now when you're solving for x-intercept, right, you need to have the x-intercept. So x-intercept y is equals to 0. We know that this is an exponent, so it's just going to be 2 to the power of 0. And then this has got no choice but to be on this side of the equation. Yeah, then from there it means x is equals to 2 to the power of 0 minus 1. So it means here in this case x is equals to 1 minus 1, so x is equals to 0. So it means in this case the y-intercept is also there. The x-intercept is also the y-intercept, so it passes through here. So you always have to find the y-intercept and, the x-intercept and one other point. So you can find any point in the graph. So for instance, I'm gonna substitute, you can substitute any point. So if I substitute maybe 1, right, x is 1. So if I choose x as 1, it means I'm gonna have y is equals to log, okay, fine, log 1 plus 1 base 2. Okay, fine, it's not literally gonna write there. So y is equals to log 1 plus 1 base 2. So this is the same as log 2 base 2. So if you type in the calculator, you'll get 1. So it means that we have got our coordinates. We chose 1, right? And we also got 1. Yeah. So you literally choose any point over there. Like you literally choose any point, right? You choose any point in place of x. Maybe you can even choose 2. And you have to see what y value it will give you. So from there you have to figure out where is this in the graph. So 1 is to 1. It's somewhere here. This 1 is to 1. So from here, just from these 2 points, and this is an exam, by the way, they like saying draw it with one other point. They do it on purpose. Yeah. So logarithm graph has two shapes, right? In this syllabus, it has two shapes. It's either it's gonna be like this, or it's gonna be like this. Only two shapes. So by these 2 points, we can tell which one of the two it is. So it has to be this shape. If the other point was here instead, and this was the point, we would have said it has to be like this. So that's how it is. So that's how you draw the logarithm graph. Let me give you another example. Let's say y is equals to half. Let's say half to the power of x. So you have to find x-intercept. X-intercept y is equals to 0. So you will have half and then x. So it means that the base is still the base, and the exponent, okay fine, the subject to the formula is the exponent, and then it means x has no choice but to be there. Yeah, it doesn't matter whether you put this on the left side or on the right side. Yeah, but, or if you want, you can even put it on the other side, so you can say this is the base, so then this is gonna be half, and then this the exponent. The answer is always the exponent. So anything to the power of 0 is 1, so it means this is gonna be 1. So we found our x-intercept, so our x-intercept is at 1. So it means when I draw, okay, I have to start with the asymptote first. Notice that we have got x only, so it means that there is a plus 0. So it means that the asymptote is 0. The vertical asymptote is 0. So it means the y-axis is the vertical asymptote. So you literally have to say y is equal to 0. And then we got our x-intercept as 1. It looks like a 2, but I meant for it to be 1. So let me just write it like this. So our x-intercept is at 1. So we have to find one other point. So on this graph, I'm going to choose my x as 1, so as half. Let me choose as half. If I choose half, the calculator is going to give me 1. So it means I'll choose half, and then the calculator will give me 1 as the answer. Yeah, so if you choose half here and you type in the calculator, y is going to be 1. So that's how it is. So where is half and 1? If x is half is somewhere here, 1 is somewhere there. So it means that it will be somewhere here. So from these 2 points, we can tell how the graph is supposed to be. Remember, it's either like this or like this, but obviously it has to be like this, right? It's either like this or this way, but anyways, because of these 2 points, that's how it is. So okay, let me just try and draw it a little bit better. Yeah, so that's the graph. So that's how you draw a logarithm graph.